every open cast mine eventually asks, what does it actually cost to move 1 ton of material by truck? Not a rule of thumb, a full owning and operating cost built up from cycle time, fuel, tires, maintenance, crew and capital all in one place. In your browser, no installation, no internet connection needed. The layout follows one logic: inputs on the left, results on the right. Up top 7 live KPI cards, number of trucks, cycle time, fleet throughput, fleet daily, fleet annual, cost per ton per kilometer. Every one of them recalculates the instant you change an input. This side is the input with no calculate button to press below, but it will use the slider. Below that, 3 charts. There are 3 charts and 3 tables. 3 tables break the numbers down every way a mine planner or a finance team would want to see them. Let's start on the left with the truck itself. First, let us select the truck model. Here there are a lot of trucks in the list. Click any trucks and this will reflect the trucks. Apart from that, if you use a custom, then you can have different choice of the dumpers. Like say here now I am choosing say 100 ton dumper. Payload capacity, this is the rated tonnage. So actually by dragging this slide you can change the capacity of the dumper. Below that there is a slider for the number of trucks. This truck number also you can change, and correspondingly these KPI cards will also be changed, all the values. So here let me select 10 number of trucks, and thereafter the load factor. Load factor accounts for the real world unloading, underloading. Most fleets do not run at full rated payload every cycle, and this correction keeps the numbers honest. Then there is a slider for the specific gravity, and this is mainly if I want to calculate for the overburden, then I can increase the specific gravity, and for coal actually it can be 0.8 ton per cubic meter, and for overburden we can increase it as per the requirement. Then there is haul profile. That is, haul profile is where the distance does the damage. Watch the cost per ton card. As I extend haul, the cost climbs as distance grows. You can see that these are all changings. So now let us keep it say 3 kilometer. Then another important thing, that what is the haul speed. So with the increase of the or decrease of the haul speed, again the productivity shall change. That is, suppose if I make the haul speed loaded, say 17 km per hour. You can see the cycle time it will change. Similarly, the return speed also it will control the total cycle time. So this you can select as per the requirement. And then the ruling grade 1 in n, that is, suppose if I make it steeper, you can see the 1 in 11 is 9.09% grade and 5.19 degree ramp angle, and grade resistance is 91 kg per ton. So actually this also you can control. Now say I am keeping it 1 in 15. Then actually I can also change the spot and dump time and loading time. So these total things, that is speed, distance, and the spot and spot of dump time and loading time, this will determine the cycle time. And cycle time means total throughput also, it can be controlled. Then there are operational parameters, like say operating hours per day. So this is, suppose if I increase it, automatically this production fleet throughput it will increase. Then mechanical availability, that also I can change. Operational utilizations, that also I can change. And working days per year, these also I can change. Then comes the section of the cost parameters. Cost parameters is the owning and operating engine, fuel price, burn rate, then tire cost, tire life, repair and maintenance as a percentage of capital, depreciation, residual value and finance rate. Every one of these is editable because every mine's contract rates are different. Here I have put a special note, that is crew per truck, 3.5 numbers. So whatever may be the driver wage, that will be multiplied by these crew numbers. You can see the remarks, crew per truck is equal to total operators needed to keep one truck running across all shifts in a day, driver plus rate, and these costs are reflected here. Then also the truck purchase price. Now say 100 ton dumper, it is something like 4.30. I have kept 4.30. Then repair and maintenance, and then depreciation period, residual value, interest, finance rate. Everything I can set it here only by these sliders. Then let us come to the KPI strip. This is the summary a client needs in 5 seconds, that is fleet size, then cycle time, throughput per hour, per day, per year, and the two numbers that matters most, cost comparison, all in cost per ton and cost per ton per kilometer. So you can compare this haul against a completely different one on equal footing. Then I am coming to the next section, that is the cost breakdown. Here you can see is the total OPEX and this is total owning cost. So total owning and operating cost is 5.25. So total fleet cost multiplying by the number of trucks, this is also showing, and this is a pie chart that answers where does the money actually go. For one truck, 1 year, fuel, lubrication, tires, repairing, driver and labor, depreciation, which is exactly why the fuel price and the burn rate sliders that affect so much. So this is also showing exactly rupees and also the percentage of each cost element of the total cost. Then the distance versus productivity cost chart. This is drag. So if I increase the one-way haul distance, so this will change. You can see that one-way haul distance, if I change, then the each and every, here also the haul distance is there, and if I touch this point, it is showing 3 km haul and tons per day 2289 and rupees per ton is 69. So same thing, this is tons per day per truck, and this is the rupees per ton. So any point if I touch, then it will show the respective figures. Then I am coming to a very important chart, that is fleet size sensitivity. This annual production in million ton per year and total fleet cost. So now actually we have selected 10 number of trucks, so it is coming here, and if I put the cursor, then it is showing 7.56 million ton per year and 9.44, that is if I convert it into the bank cubic meter, then it is converted into that. So this also you can see 7.56 million ton. With the specific gravity, if I increase the specific gravity to say 2.1, this becomes 3.60 bank cubic meter, and 7.56, that will remain same. So here also it will reflect the same thing. So like this, suppose I choose here, say, then again entire relationship will change. Suppose here I put 27 number of dumpers, so it will show the result. It can give 18.56 million ton per year, that is 8.84 bank cubic meter for OB with SD specific gravity 2.10. And then in the finally, this charts, these three tables are showing the entire report, that is cycle time analysis. All these figures it is showing, per truck cost also it is showing, fleet summary also it is showing. So all these things will be shown, and so and this sheet can be saved as individual HTML and can be distributed. It is possible to share the URL, and also it is possible to export the PDF report. You can see this is a PDF report also can be generated here. So all these facilities are here. So that's the dumper economics calculator, from cycle time to crew cost to fleet sizing in one offline sheet. If you are a student, this is exactly how a real owning and operating cost model is built. If you are a client, this is exactly how we will build yours. So thank you very, very much.